Okay, so this video is going to be an intro to Unit 2, which is basically just Chapter 2 in your book, if you're using your textbook. And so the main thing that we're going to focus on for the first lesson here is something called if-then or conditional statements. And every conditional statement has two parts, the hypothesis and the conclusion. And so the hypothesis is the phrase that directly follows the if. So in this case, "You're Mr. Smart" is the hypothesis. And the conclusion is the thing that directly follows the then, which is "You love the Dodgers." By the way, this is true. If you're Mr. Smart, you do love the Dodgers. Okay. And notice that when I label the hypothesis and the conclusion, you actually leave the word if out of the hypothesis and leave the word then out of the conclusion. Okay, so it says give some examples of some conditional statements. So you're supposed to come up with your own. I'm going to give you a few right here. So example 1, let's say, I'll do a couple of math ones. So if x plus 4 equals 7, then, well, you can solve that. X has to be 3, which is true. You know, that's true. I'll color code these. So example 2. I'll do another math one. So if, ooh, what's going on with the pen? If, let's say, an angle Hold on, let me see if I can fix this. Okay, if an angle measures 100 degrees, then the angle is obtuse. Right? And then we'll do one more here. Example 3. So I'll do, I don't know, a non-math one. If you're in 9th grade, then you're a freshman. And so in all of these are true. So let's look at number 2. What's the hypothesis of the example that you wrote in number 1? So maybe you just wrote the ones that I did, but in example 1, the hypothesis is the phrase right after if. So it's x plus 4 equals 7. And then in example 2, the part that came right after the if was an angle measures 100 degrees. And in example 3, it's you're in 9th grade. Okay. In number 3, it says, what's the conclusion of each of these? All right. So in example 1, it's the part that comes right after the then. So in example 1, it's then x equals 3, so it's just x equals 3. And in 2, it's the angle is obtuse. And in example 3, let's see, what is it? It's you're a freshman. Okay. So there's how hypotheses and conclusions work. In number 4, it says, it's talking about something called a converse. And the converse of a statement is when you just switch the hypothesis and the conclusion. So in the original statement up here, it says, if you're Mr. Smart, then you love the Dodgers. The converse would come if I switch these two guys. So then it would be, if you love the Dodgers, then you're Mr. Smart. Right? Which it says down here, if you love the Dodgers, then you're Mr. Smart. The if and the then stay put, right? Because those aren't actually part of the hypothesis and conclusion. So then is the converse true? Is this statement that I just said right here, is that true? Well, in this case, it's not. No, not true. By the way, if it's not true, you'd say it's false. It's got to be true all the time to be true. Otherwise, you just say it's false. So it's not true because there are people besides Mr. Smart who love the Dodgers. And if you don't believe me, well, my relatives love the Dodgers, so there. So, and they're not all Mr. Smart. All right. So let's go back and try finding converses for number 5. Oh, by the way, yeah. Oh, no, we answered that. All right, number 5. Find the converse of the statement you made up in number 1. Okay, so here are the examples right here. If x plus 4 equals 7, then x equals 3. So if we switch that one around, that's going to be if x equals 3, then x plus 4 equals 7. So we just flip it around. So example 1, if x equals 3, then x plus 4 equals 7. That's the converse, right? And is it true? Yeah, if x is 3, well then 3 plus 4 is 7, so yeah, that's true. Right? I'm not going to explain why. I mean, if you plug in the 3, it works, right? So in example 2, let's reread example 2. So example 2, if an angle measures 100 degrees, then the angle is obtuse. So in this one, you'd switch the angle is obtuse with an angle measures 100 degrees. Although it sounds a little dumb if you say, if the angle is obtuse, then an angle measures 100 degrees. So instead, you kind of fudge the wording a little bit so it makes more sense. So instead of saying if the angle is obtuse, you'd say if an angle is obtuse, then the angle measures 100 degrees, right? Because it sounds a little bit like it makes more sense that way. So if an angle is obtuse, then the angle is 100 degrees. Well, is that true? No, not really. If all obtuse angles were 100 degrees, then you could say that statement and that would be true. But there are other obtuse angles, right? So it's kind of like the if you love the Dodgers, then you're Mr. Smart example in number 4. There's more than one person besides me that loves the Dodgers, just like there's more than one angle that's, there's more than one 100-degree angle that's obtuse. There are other angles that work too. So this one's false because being obtuse doesn't mean the angle has to be 100. The angle has to be 100 degrees, right? It could be like 92 degrees or 170 degrees. So, and then let's look at example 3 again. So the original was if you're in 9th grade, then you're a freshman. So the converse, switch your freshman with your 9th grade. So if you're in, if you're a freshman, then you're in 9th grade. And that one, if you're a freshman, yeah, you have to be in 9th grade, so that is true. Okay, I don't know. I guess you could argue it's false if you say freshman in college is different, but whatever. For our purposes, we can say that's true. All right, so number 6, circle the hypothesis, box the conclusion, determine if it's true, state the converse, determine if the converse is true. All right, so let's see. Circle the hypothesis. Well, the part right after the if is the hypothesis, so I'm just going to put an H there. Box the conclusion. Right after the then, that's the conclusion. Is it true? Well, if 4x is 8, then yeah, x has to be 2. So this is true. Let's write the converse. So the converse would be, if x equals 2, then 4x equals 8, right? So is that true? Well, yeah, if x is 2, then 4 times 2 equals 8. That's always the case. So this is true. So notice in this one, the original and the converse are both true. Okay, let's take a look at the next one. If a equals 3, then a squared equals 9. Well, hypothesis is right here. Conclusion is right here. If a is 3, and then you plug it in, 3 squared, that does equal 9, so that's true. The converse would be if we flip, so that would be if a squared equals 9, then a equals 3. Okay, that's actually false, because it turns out it doesn't have to be 3 every time, right? Because a could also equal -3. So if you look back here, if a squared is 9, then a is 3 or a is -3. If it said or -3 or it said plus or minus 3, then this would be true. But in this case, because it only says +3, it's false. Okay, this one has a new symbol in it, congruent. That symbol right there, I'll put it over here, star. This symbol means is congruent to. And so informally, here I'll write it down so you have it. So informally, it's used to show objects are the same size and the same shape. So if you think about it, okay, if two angles are congruent, so if they're the same size and same shape, then their measurements are equal, right? The degrees of A should equal the degrees of B. That's definitely true. So this part, by the way, is the hypothesis. This part's the conclusion. Okay, so we got that. And then the converse. So if the measurement of angle A equals the measurement of angle B, then angle A is congruent to angle B. So if you have two angles and you know that their degrees are the same, well then yeah, they're the same size and they're the same shape. So this is true too. So in this case, the original and the converse are both true. Whereas in B, the original was true, but the converse was false. Oh, I forgot to write false. Oh no, it's here. Okay. All right, so let's look at 7. So in 7 it says, consider the following two statements, and they're converses of each other, and they're both true. If two angles sum to 90, then the angles are complementary. Or, if I flip it around a little bit and then reword it so it makes more sense, if two angles are complementary, then the angles sum to 90. They're both true. They're both true, right? Anytime you have two true if-then statements that are converses of each other, right? If A then B, if B then A, they're both true. You can combine them into one statement instead of having to write two if-thens. And the way you do it is you take the hypothesis and the conclusion of either one, and you write them down here, and you stick the phrase if and only if in the middle. Two angles sum to 90, if and only if the angles are complementary. That doesn't matter if you do it with the original one or with the converse. So if you did it with the converse instead, you'd say two angles are complementary if and only if the angles sum to 90. Either one's okay. They both say the same thing. And that's called a biconditional statement because it's like a two-way conditional. The first thing means that it means if this, then that, and if this, then that. Right? So it's two conditionals, really, combined into one. So let's go back and look at number 6, and we'll find the statements that are true that also have true converses. So in that one, 6a was one of them. If 4x equals 8, then x equals 2. If x equals 2, then 4x equals 8. So if I want to combine those into a biconditional statement, that's the if and only if version, then I'm going to write, so this is number 6a. So 4x equals 8 if and only if x equals 2. Right? Or if you had decided to use the other version of it, you could have written x equals 2 if and only if 4x equals 8. That would work too. Okay, 6b had one true, one false, so we're not going to bother with 6b. But 6c, both were true. If a is congruent to angle b, if angle A is congruent to angle b, then measurement of a equals measurement of b. And if measurement of a equals measurement of b, then angle A is congruent to angle b. They're both true. So we can combine them. So to combine them, we take the hypothesis of one of them, doesn't matter which one, and then you say if and only if, and then you use the conclusion of that guy. A is congruent to B. Okay, or you could have flipped them around. Angle A is congruent to angle B if and only if measurement of B, A, sorry, equals measurement of B. Okay? So remember, complementary means two angles that add to 90. Just so you know, in the homework, there are some questions about complementary, but there are also some questions about supplementary. Supplementary angles are a pair of angles that add to 180. So just remember that, okay? I think it mentions it in the homework anyway. Okay, so the last question is just kind of one of those solve for x type questions. So P and Q are complements. Find x, measurement of P, and measurement of Q. Okay, so I'm going to just write here, P and Q are complements. So that really means then if I add up P and Q's measures, then I should get 90 degrees, right? Because that's what complementary angles are. I'm going to write this here because this will lead into our next lesson. This is called the definition of complementary angles, right? Complementary angles. If you know that they're complementary, they better add up to 90. Okay, well, P is 5x plus 13, and Q is 2x plus 14. And those put together equals 90. By the way, this is what we're doing here is we're substituting. Right, I'm taking what I know angle P is and what I know angle Q is and plugging them in for the P and the Q. So then if I simplify this, let's see, that's going to be 7x plus 27 equals 90. So 7x is going to be 90 minus 27, what is that, 63? Let me just make sure, yeah, 63. And then if I divide by 7, x is going to end up being 9. So there's x. Are there blanks for this one? No, no blanks. Okay, let me shrink this down so it fits a little bit better. Okay, so now we need measurement of P. Well, P is 5 times 9, because that's x, plus 13. So that's 45 plus 13, which is 58. And then measurement of Q is going to be 2 times, 9 plus 14. Oh, I don't know what's going on with the marker here. So that's 18 plus 14, which I think is 32. Let me double check that. Yeah, 32. And then a quick check, well, you know these two added together better be 90, which is what they end up being. So these guys are all good here. Okay, so I hope that helps a little bit. And for homework, I want you to try the Unit 2B handout. Okay, thanks.